Hi class, my name is Nathan, and for this week's assignment I've decided to explore option 2 of our discussion board, which is finding some sort of lab that could be used in a high school to explain the failure moments of both axial and bending when it comes to materials. So I'll first start by kind of describing what I've selected for my material. Very easy to get. I just got a couple different sizes of crayons here, which are the same material, but the key difference is that they have different diameters. So this is going to be what I'm using for my labs, and as you can see just by observation of both, they are both the same type of material, but the diameter is different on those. And to help prepare these for the lab, what I've done is I've cut the tips off the end of them, so we're dealing with a straight column structure for both sizes. And I've also made sure that the length is the same as well. So the small crayon is going to be 0.3 inches in diameter, where the larger size is ½ inch diameter, and they're both 3 inches in length. So that gives us a good starting point to make sure that our lab is going to be accurate all the way through. To start, we're going to start with compression first, and we're specifically looking at the buckling formula, which I have laid up on the screen. I'm going to try to attach this to my discussion post because I understand it's probably a little hard to see. But a little bit of research, I discovered that paraffin wax, which is the main material that is used in crayons, has elasticity of 55.7 MPa, which is 8078.6 psi. The other variables are length, which is 3 inches, and then our diameter, which is going to fluctuate between the two sizes, between 0.3 and 0.5 inches. And then because we're just going to be compressing this from the ends, we have a K value of 0.5. So moving on and plugging those values into the formula, we can see that it takes 13.5 pounds on the smaller diameter crayon and over 100 pounds on the larger diameter crayon. To compress that in the lab, I thought a tool such as this bar clamp here could be used. And you could even put a pressure plate in between it, so you could get like a maximum pressure just to verify that these numbers were right. But I can tell you just by giving a little bit of squeeze on these things, they do bend a little bit before they break, but it's nothing too dramatic. So it's definitely something that you'd want to do in person in the lab. And just to kind of demonstrate here, as I compress this, see a little bit of bending, and then it breaks and shoots off across my room. So that would be the first example. The second example is going to be the bending equation. So here's the bending equation here. We have moment times radius over the second moment of area. And for this example, I'm going to use 10 foot-pounds of force. You're going to want to set this lab up so you have a singular point in the middle that's bending the material, and then you have your fingers or material on the outside that's pushing in the opposite direction, so you can see that bending occurring. The small crayon, the bending stress with 10 foot-pounds is going to be 120 pound-inches, and so because it's such a smaller diameter, we're getting about 45,000 psi is going to be the bending stress on this, where the large crayon is showing under 10,000 psi. So when you look at factors of safety as far as this is concerned, we can understand that by having more material and a larger diameter, the crayon itself, or whatever material you're using, is going to be able to withstand more torque, more bending stress than a smaller material might be able to. Another thing that I found interesting in my research is that depending on the color of crayon, they're either stronger or weaker depending on that. So I thought it might be a good idea, after this is explained to the students, to recommend that they take a box of crayons and see if they can figure out which color is not only the strongest but also the weakest. And again, you would need some tools in the lab to be able to verify the different pressures that we're using in those forces. So hopefully you found this valuable. If you have any questions, feel free to post in the comments below. And I wish everyone good luck. Thank you.